we are kicking off the year with CO1, which is classifying a number as rational or irrational. Now, last year in pre-algebra, your CO1 was classifying a number as a whole number, an integer, a rational, or an irrational. I'm kind of hoping we remember what a rational number is and what kind of makes something rational versus irrational. So, think back to last year. What is a rational number? Yes?
Is it a decimal?
It can be a decimal. There's a caveat to that. That's part of it. What else do you remember, Henry?
Can it be a fraction?
It can be a fraction. James?
I could say an example of it. Never mind. Never mind.
It can
James?
be a whole number?
It can be a whole number, so then that begs the question, what's a whole number?
Not a
Lucas?
whole number.
A rational number is
Any number that doesn't go on forever without the repeating.
So that's the second half of what Peyton said, right? It's a decimal that ends or repeats. Okay, a decimal that ends or repeats. So basically, a rational number is any positive or negative fraction, non-decimal, which is where things like whole numbers and integers come into play here, fraction, non-decimal, or decimal that ends or repeats. A rational number is any positive or negative fraction, non-decimal, or decimal that ends or repeats. So, someone mentioned whole number. What's the definition of a whole number? Where does a whole number fall into this here? Henry?
a negative for positive. It can be 1, 7, negative 3.
Okay, so you're actually thinking integer. Okay? An integer is any positive or negative non-decimal. Okay, that's where integers fit into this rational definition. They're any positive or negative non-decimals, like 7 or negative 3 or whatever else you said. You were all correct there. Okay? Where do whole numbers fit into play? Or come into play here? If a number is whole, what's the definition of that? Jude, hey Jude.
Is it a positive number that isn't a decimal or a fraction?
Right. A whole number are all the positive non-decimals. So whole numbers and integers are very, very similar in that they're both non-decimals. The difference is positive or wholes have to be positive. Integers can be positive or negative. Okay? Rationals include all wholes, include all integers, as well as any fraction or decimal that ends or repeats. What's the symbol that tells us a decimal ends or repeats? Who knows that one?
Is it like, never mind.
Tipton? Is that hand up? No? Emerson?
There's like a line that goes over top.
Yeah. If your decimal is like 5.171717171717, you'll find out that math people are actually really, really lazy. If we can shorten something up, then we'll do it. Instead of writing 17171717 forever and ever, we just put a line over it. Ah, that tells us that that decimal repeats. Okay? And because it repeats, then it is considered rational. And the reason for that is that any decimal that does repeat can be written as a fraction. This is kind of the key here. Fractions. Okay? We know that decimals and fractions are related. You practiced converting them back and forth last year. And if a decimal repeats, or if it ends, it can be written as a fraction, thus the rational category. Okay? Huh?
Like 0.3 repeating.
Like that. 1/3. Yeah. Yeah. So, what's an irrational number then? We have all these rationals. What's an irrational number? Damien.
It's a number that goes on forever. Just repeats the decimal.
Yeah, that does not.
Oh, does not go on forever.
Well, it does go on forever without any repetition, right? It is a decimal that does not end or repeat. A decimal that does not end or repeat. What is probably the most famous irrational number out there? Madden.
Pi.
Pi. Pi is the one that's most frequently used. It is 3.14159, blah, 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 blah. Okay? They've got computers that their only job, your one job as a computer, is to compute pi. They've got it out to 2 billion plus digits. There's no end, no pattern, no repetition. Therefore, it is irrational and used all the time with circles. Okay? Your general irrational number, any decimal that does not end or repeat. How do we show that a decimal goes on forever without repetition? Do you know the math symbol for that? Christian?
It's like a dot, dot, dot.
Exactly like the dot, dot, dot. If you were to put the square root of 83 in your calculator, go ahead and take out your calculator. If you don't know how to use the root button is, well here's your calculator here. We'll draw a little calculator here, okay? Here's the display up here. Up in the top left is a button that says second. That's like your shift key. You know how on a computer when you want the dollar sign, you have to put the shift key first and then hit the 4, a capital letter, things like that. That's like your shift key. Now below that, right around the 7, and I'm making these buttons obviously larger so you can see them, is a button that says x squared. Okay? Above that, not on a button, but on the calculator itself, is the root symbol. Does everyone see that?
Yeah.
Okay? Notice the root symbol is not a button, right? It's printed on the calculator. When that happens, that means you have to push the shift key or the second function key first. Okay? So to do the root of 83, you're first going to push that second button. Okay? Then you're going to push the x squared button, but what shows up in your display is going to be this. A root symbol with a given parenthesis. Because you pushed that second function first, you said, no, I don't want what's on the button, I want what's above that. Okay? Everyone good so far? Okay? Then you're going to type in 83, close your parenthesis.
Oh, I didn't close it, I still don't remember.
So we'll talk about why you should get in the habit of closing them later on, when we get more order of operations stuff. If you don't close it, you will get the same answer. However, if you get in the habit of sometimes closing, sometimes not closing, then that's when you start to miss stuff with the order of operations. So it's a good idea just to always close it, just make it a habit. But anyway, what decimal do you get here? What do you come up with? Kyle, read it off for me, please.
9.110433579.
Okay, and the only reason why those numbers stop is because your calculator runs out of space. Okay, in fact, this decimal goes on forever. So like Christian said, and I'm going to write this a little bit smart. Colin, can you read it off for me again? I wrote it too big, sorry. 9.11 what?
9.110433579.
Okay, so really, this decimal goes on forever, and we would show that by putting a dot, dot, dot. That means it goes on forever, it's an irrational number. And perhaps you remember talking about perfect squares and non-perfect squares? Do those terms ring a bell?
Yes.
Okay,
Yeah.
83 is a non-perfect square because you get a decimal answer and you take the root of it. Every non-perfect square is an irrational number. Every single one. Okay? So give me another example of a non-perfect square. That would be an irrational number.
8 squared 84.
The root of 84 would be irrational. Give me another one.
7,963,278.
I'll take your word for it. Give me another one.
75.
75, okay? If something's a perfect square, it'll always be rational. Like the root of 16. The root of 16 equals 4, exactly 4. Right? Because 4 times 4 is 16. So perfect squares, I should put this up here, sorry. Perfect squares are always rational. Non-perfect squares are always irrational. I say that here too. The root of any non-perfect square is always an irrational number. Questions so far? Okie doke. Time for you to practice. I think this is a one-pager today. Is it going to?
Yes, it is.
It's a one-pager. Way to start
I love my life.
Way to start the year. It says label each number as rational or irrational check your answer by explaining why you chose the category you did. So if I see your paper tomorrow when I walk around for the homework check, and all I see are a bunch of R's and I's, you're not getting credit. This is the showing work part. Why did you choose rational or irrational? Doesn't have to be much. I'll do an example. Negative 19.7, rational or irrational? Rational. Why? It ends. R ends. That's a horrible E. I messed that up. R and it ends. That's all you need. Just something other than R or I. Root of 36. Rational or irrational? Rational. Why?
Because it ends.
It ends. You could write that. You could
Whole
also
number.
say it's a perfect square.
Whole number.
Okay, it ends up being a whole number. 6, exactly. 30 seconds. Rational, irrational? Rational, why?
It's a fraction.
You could say it's a fraction.
Because it ends.
You can say the decimal ends. It is simply 0.5. Either one of those will be fine. How about pi?
Irrational.
Irrational, why?
Because it goes on forever.
Goes on forever and ever and ever and ever. Okay? Questions on that first part? Second part says answer each question. It says write the value of 9 3 ways. As a negative integer, so we kind of bring back integers a little bit, a fraction that's not in simplest form, using an exponent, and using a square root. So I say write the value three ways. I give you 4 options. You need to choose 3 of those 4. Okay? Using a power to get a value of 9. Using a root to get a value of 9. A fraction not in simplest form, or a negative integer. Then in our number system, are there more rational numbers or more irrational numbers? Explain. And for review, describe what whole numbers and integers are. Now, when you walk in the room tomorrow, there will be a timer set up, a 5-minute timer, and in Google Classroom there will be a bell ringer posted. The bell ringer is 5 questions that come directly from this homework. The idea being, if you do your homework, you already have the answers. Doesn't mean they're correct, necessarily, but you have them. Okay? So when you come in, I'll be walking around checking around homework. While I'm doing that, you're working on the bell ringer questions. It's a Google form. You'll submit it. You'll see your score immediately. If it is less than 4, you can retake it that evening to get 100%. A 5 out of 5 is 100%. A 4 out of 5 is 100%. Anything less than that, a 3 out of 5 would be 0.6 out of 1. A 4 out of 5, 2 out of 5 is 0.4 out of 1, and a 1 out of 5 is 0.2 out of 1. Okay? I'll reopen the Google form. I'll review this tomorrow. I'll reopen the Google form by 2:30 p.m. And you can retake it as many times as you need to boost your score up to 100%. I shut it down at 8 p.m. and that's when I enter scores into Blackboard. So from 2:30 to 8 p.m., if you don't get 100% the first time around, that's your opportunity to retake it until you do. And guess what? We go over all the answers in class. So it's really hard. It's really tough to explain to parents come conference time when I sit down and say, yeah, no, these bell ringers, like your kid's getting 3 out of 5, 2 out of 5, 1 out of 5. And they're like, oh, well, can they retake it? Yeah. How do they know what the answers are? We go over every question. Oh, you do? Yeah. So my kid's just not putting an effort. Bingo. Okay? These are freebie points. These are points that everybody should get every day. Okay? So, start the year off strong. Expect that tomorrow. Again, I'll explain everything else once you actually see it. But bring your computer. Make sure it's fully charged, because if you don't have your computer, it's not fully charged, then you don't get to do it, and that's when we get problems. Lucas, thanks for being patient. Go ahead.
Do we get Schultz bucks for those?
For those, no. No. You get Schultz bucks in a variety of ways. Test scores. If you did the football pick'em thing.
When do they start getting Schultz bucks?
I keep them in the bank of Schultz. Bank of Schultz, actually. German bank. And I tally them up, and you get them at the end of the year. I used to hand out actual dollars in the past, but then people would come and say mine were lost, mine were stolen, it just got me messy. So,
That should be their fault though.
Yeah, that's what Mr. Robinson said.
Yeah,
It's their
if you
fault.
lose it, you
yeah, but then the whole theft thing, I don't know. It got to be too much, so.
But then there's theft.
Emerson.
If our siblings left any shells, what do we get them?
Yes, if you do have an older sibling that I've had before, if any were left in that sibling's account, they are automatically transferred to your account.
Wait, no, I can't.
So my
So,
siblings.
if you have multiple siblings,
Oh, wait, no, it's actually stolen. They wouldn't have anything but.
I have a question.
no idea. I can check, but I'm not. Okay, 3, 2, 1, you are quiet. Any questions, comments, concerns, complaints, compliments, congratulations, criticisms on the homework? This is due tomorrow, the rest of CO1, or anything else we talked about today. Damien, go.
I don't think I'm in the Google Classroom.
All right, I'll put up the code once we're done recording for those who still need to hop in there. Anything else? Okay, do you remember what we practiced?
Oh, yeah.
Okay.
Yeah.
I'm gonna do my,
at football.
that's not what you say. I'm gonna do my part, and then you say it. Ready? Okay. That's how you math.
Don't forget to like and subscribe.
Oh, that was a little
Turn
loud.
on notifications.
No. We don't want to make it too. It was basics. I want the stuff. I want the
You gotta
basics.
edit this
Okay.
out.
I don't know how to edit. Whatever it is.
I do that.
No. Whatever happens in class just gets put up there. So I don't know how to edit these things. Okay. We'll try it again. Don't forget to like and subscribe. Here we go. That's how you math.
Don't forget to like and subscribe.